Imagine tracing your whole route by hand, a giant atlas open in your lap, dreading every missed exit and each wrong turn. A single detour meant page flips, confusion, maybe even pulling over to ask a stranger. Today, over 4 billion people navigate the world with satellites and smartphones. Maps have vanished, almost overnight. How did an entire way of life disappear in a generation? A kitchen table becomes mission control. A thick Rand McNally road atlas sprawls across the surface, pages creased from years of family trips. Highlighters and pens scatter nearby, ready to plot the route from one state to the next. The ritual begins with tracing highways in neon yellow, circling gas stations, and penciling in rest stops. For longer journeys, there's a stop at the local AAA branch. An agent behind the counter consults a wall of maps, then assembles a custom triptych, a spiral-bound flipbook showing every turn, intersection, and speed trap along the way. Each segment is marked by hand, sometimes stamped with warnings about construction or scenic detours. The map itself feels sturdy, almost reassuring. Fold-out state maps and Thomas guides fill glove compartments, their grids promising order but hiding a secret. Every new bypass or closed road is a potential trap. Map kiosks stand like sentinels at gas stations and motels, offering free city maps for travelers who forgot their own. Drivers memorize routes, jot down notes, and hope they've remembered every step. A missed exit means flipping back and forth, trying to find where the road disappeared, or pulling over to ask for directions. The process is slow, tactile, and filled with small moments of doubt. Yet for decades, this was the only way to navigate. A world where every journey began with paper, ink, and a leap of faith. A fresh map in the glove box rarely stayed accurate for long. Highways shifted, exits vanished, and whole neighborhoods sprang up overnight, leaving last year's atlas already behind. A bright yellow line might promise a smooth route, but one unexpected detour, maybe a bridge out or a new bypass, could turn that promise into hours of backtracking. Drivers found themselves stranded on unfamiliar roads, squinting at tiny print, trying to spot a county line or a faded mile marker in the dark. Fold-out maps fought back, refusing to fold the same way twice, their seams tearing just where the next turn was supposed to be. Even a well-prepared traveler armed with a triptych could run into trouble when construction crews rerouted traffic, leaving hand-stamped warnings 2 states behind. A missed exit meant wrestling with a paper maze while cars whizzed past, or pulling into a gas station to beg for directions from a clerk who might not know the way. More than one family remembers a detour that turned into a 300-mile mistake. The highlighter trail on the map ended in the middle of nowhere. For all their charm, paper maps could not keep up with a world in constant motion. The need for something faster, more reliable, and always up to date was growing with every wrong turn. In 1973, deep inside the Pentagon, a handful of engineers set out to solve a problem that had stumped generations: how to pinpoint any location on Earth, day or night, in any weather. The breakthrough came from the minds of Roger L. Easton and Bradford Parkinson. Easton's work at the Naval Research Laboratory introduced the idea of orbiting atomic clocks, so precise they could measure a difference of a billionth of a second. Parkinson, an Air Force colonel, took that vision and convinced the military to fund a new system, Navstar GPS. The concept was simple in theory but audacious in practice. Each satellite would broadcast a unique timing signal. Receivers on the ground would listen for at least 4 of these signals, then use the speed of light to calculate distance from each satellite. This method, known as trilateration, made it possible to fix a position with astonishing accuracy, within 10 to 15 meters for the military, thanks to those atomic clocks ticking thousands of miles above. The first Navstar satellite launched in 1978, but early civilian receivers were massive, expensive, and intentionally less accurate. Parkinson later recalled that the biggest hurdle was satellites lasting 10 plus years in radiation, and that they iterated 3 prototypes. At first, only the military could trust GPS to guide them precisely, and everyone else had to wait for the system to open up. The foundation was set, but the leap from lab benches and military hardware to everyday use was still years away. At midnight on May 1st, 2000, the world's maps quietly sharpened. The White House ordered the end of selective availability, a decades-old policy that had blurred civilian GPS readings by design. Overnight, the average person's GPS accuracy jumped from about 100 meters to just 10 meters. Suddenly, a handheld device could pinpoint a front door instead of a football field. The change wasn't just technical, it was immediate and astonishing. Engineers watched as the jitter on their screens vanished, and hikers, sailors, and drivers everywhere noticed their location pins snap into place. But precision alone was not enough. For years, GPS chips were bulky and expensive, reserved for professionals or wealthy hobbyists. Then came the crash. By 2005, thanks to companies like CRF and their Star 4 chipset, the cost of a GPS receiver plummeted from hundreds of dollars to less than $5. Smaller, faster, and power-hungry no more, GPS was suddenly ready for pockets, dashboards, and eventually every phone. For early adopters, the first time a device called out a turn felt like science fiction made real. One yacht owner, among the first to buy a Magellan handheld, described it as trading the stars for satellites, navigation that was instant. If you enjoy discovering how technology keeps reshaping our world, consider subscribing so you do not miss the next evolution story. In 2004, a new kind of map began to take shape, not in a printing press, but online. OpenStreetMap invited anyone with a GPS to upload their own data, building a living, editable map of the world. The next year, Google Maps went live, offering free, searchable maps on any computer with an internet connection. Suddenly, you could scroll, zoom, and search for a coffee shop or a friend's address without ever touching a foldout. The experience was fast, interactive, and most importantly, always up to date. Then, in 2007, the iPhone brought GPS into millions of pockets. No more hunting for a gas station with a map kiosk. No more scribbling down directions. By 2009, Google Navigation rolled out free turn-by-turn guidance on Android smartphones, a move that stunned the navigation industry. Dedicated GPS units and paper atlases couldn't compete with a device that offered live traffic updates, rerouting, and satellite imagery, all for free. Within just a few years, maps became invisible, woven into the fabric of daily life. Every journey started with a tap, not a highlighter. The old rituals faded, replaced by a new expectation: the world's geography always in your hand. By 2015, the ground beneath legacy mapmakers had vanished. Paper map sales, once a mainstay of every road trip, collapsed by more than 90% in less than 2 decades. Rand McNally, the giant of American cartography, watched its print revenue fall by 70% after 2005, eventually pivoting to digital trucking software just to survive. The US Geological Survey, which once printed over 1 million topographic maps a year, now saw demand dwindle to a trickle, and almost everything moved online. Even the AAA triptych, a travel icon for generations, faded from paper to pixels as travelers stopped visiting branches. Meanwhile, the makers of standalone GPS devices faced their own reckoning. Sales of personal navigation devices peaked in 2007, then plunged nearly 80% by 2012 as smartphones took over. Garmin and TomTom, once fierce rivals in the dashboard wars, shifted focus to fitness trackers and aviation just to stay relevant. The numbers tell the story. A $500 million paper map industry shrank to less than $50 million, while navigation apps captured almost every driver on the road. For every company that adapted, another vanished, leaving behind empty printing presses and shuttered map kiosks, relics of a world that no longer needed them. A new ritual quietly took hold. Instead of unfolding a map, drivers tapped an app, watched the blue dot glide across the screen, and trusted every turn to a voice from the dashboard. Waze, launched in 2008, turned millions of commuters into real-time traffic reporters, weaving a living map out of their daily drives. The convenience was addictive. Routes updated instantly, traffic jams were sidestepped, accidents were spotted before sirens even sounded. But as navigation grew effortless, something else began to fade. In 2008, a University of Tokyo study tracked 74 people navigating city streets. Those who relied on GPS wandered farther, missed more turns, and forgot landmarks faster than those using paper maps. The skill of building a mental map, once second nature, started to slip away. Meanwhile, the technology's reach raised new risks. In 2018, a major location data scandal revealed that even with tracking switched off, millions of phones kept sending their whereabouts to tech companies, sparking a global privacy debate. As dependence deepened, engineers pushed for the next leap, multi-constellation receivers blending GPS with Galileo and Beidou, and new 5G positioning promising accuracy within centimeters. The world's sense of direction, once shaped by paper and memory, now depended on invisible signals, and the next breakthrough was already on the horizon. The world now orients itself by signals invisible to the naked eye. As new navigation systems emerge and digital maps reshape our sense of place, one truth stands clear. No technology stays on top forever. Subscribe, watch the next story, and stay curious. The next revolution is already on the horizon.